Today I'm going to show off my latest creation, which is the TouchedOut synthesizer. It is a polyphonic, subtractive, capacitive touch synth. Polyphonic, it can play up to 8 notes at one time. Subtractive, which means it generates a signal, a frequency using an oscillator, digital, and subtracts out different frequencies to shape the sound. And it's capacitive in these touch pads, and it uses these MPR 121 modules, which detect changes in capacitance in what you connect them to. In this case, these pads, which is set up like a keyboard with white keys, black keys, and of course I'm using the Daisy seed for all the processing, and I've rigged up a bunch of different controls up here to shape the sound. So starting from this side, I've got a looper, and that uses a capacitive touchpad. So you click it, start a loop. I've got up and down octaves to change the octave of the frequency that's generated. I've got this cool joystick, which left and right changes the loop speed, and up and down is changes the pitch of the key that you're playing. Let's see, I've got an oscillator switch, which changes the shape. I have it sawtooth, triangle, or square wave. I have a volume knob. I have LFO controls, and you can set that on the either the volume or filter sweep, and you can change the rate or the depth of that. And then I have envelope controls, ADSR, attack, decay, sustain, and release controls. And then I have a switch down here which adds in a filter envelope in addition to the volume envelope. Over here I have a reverb knob and the main filter knob, which uses a Moog ladder digital class. And let's see, over here I've got the two MPR 121 modules, which combined gives me up to 24 touchpads, which I'm using all 24 for the keys and the three touchpads over here. Got my Daisy seed. I have stereo out and MIDI out, which I haven't programmed for that, but all the hardware is there to use this as a MIDI controller. And then I have my power, which supplies 9 volts to the Daisy seed. So yeah, different from a guitar pedal, obviously. I added these wooden ends. The back of it isn't too pretty, but I have kind of this wood piece as a structural support so the PCB doesn't bend. That's the other thing about this. This is all a single PCB, which I did for simplicity and cost. Maybe in the future I'll add a plate to go above on these controls, but I kind of like the way it looks right now. I called it the TouchedOut polysynth. I was trying to think of a name that uses the word touch because the capacitive touch, and I actually got the idea from my wife. We have 4 kids, so there are days when she is touched out. There was one day where she told me that. She said, "I'm touched out." And I was like, that's it. And she had no idea what I was talking about. But, so yes, it is the TouchedOut polysynth. I went through several design iterations, just learning about synths, learning about capacitive touch, and learning about the Arduino programming environment, which is what I use to program the Daisy seed. So when I started out, I had everything on a breadboard. I've used this for guitar pedals, but right now I've got the Daisy seed and one of the MPR 121 touch modules from Adafruit. So you connect that. It's pretty simple to connect it to the Daisy seed. You use the I2C line, and there are 2 lines for that. and then you have the power and the ground, so 4 connections total. And then for one of those, you can have up to 12 touchpads. So the first thing I did was to make this test board, which uses this conductive tape, and I connected these to the breadboarded NPR 121 and played around with that just to get familiar with the code and how that works. And then I moved on to actually designing the first PCB version that I did for this, and that is this guy, which there's some differences in the controls, minor things in the layout, and then of course it's white. And so yeah, from here I just made some adjustments to get it to what I have in this final version, which this is the PCB, which I got manufactured from JLC PCB. I also did some tests with, where did I put it? With different types of pads for capacitive touch. This is the solid one that I ended up going with, but I also tested some things out with like hidden pads that are underneath the solder mask, different designs for just kind of grids of copper, but I ended up going just with the solid one because it's simple and it looks clean and nice. So yeah, I'm going to go through the Kicad files for designing the PCB and schematic, and then I'll walk through some of the code with you. So next I'll go through the PCB design file, which I designed in Kicad. So we'll look at the schematic first. This isn't a very clean schematic. I would clean it up if I shared it with anybody. So I fit everything on one page. And here we have the daisy seed with all of the connections, potentiometers, slide potentiometers, the joystick, which is basically just 2 potentiometers. Audio output, which is stereo, the I2C line, which is what connects to the NPR 121s, the capacitive touch sensors. And both of them can be on the same I2C line. And I think you can have up to 4 of those, and I'm using 2 of them. And our switch connections, and let's see up here, all of the potentiometers. Here we have the pads, the touch pads, and the NPR 121s, which these modules I bought from Adafruit. I also bought the joystick and the slide potentiometers from Adafruit. And then we have the audio out jack, which is a small 1/8 inch stereo jack. And I also have a MIDI out, which I haven't programmed for, but I put the hardware in for that because that would be something that would be cool to do, to use that keyboard as a MIDI controller. So yes, a very cramped schematic. If I were to clean it up, I'd split it out onto different pages. So now we can look at the PCB layout. And this is a 2-layer design. On the front section, and I'll isolate that. On the front section, on the top, I have a power plane, which powers, what does it power? It powers the analog 3.3 volts. So I didn't have to draw lines out to all the potentiometers. And then I have my digital 3.3 line coming out to the NPR 121s. And then on the bottom, of course, I have the touch pads, which is just exposed copper. And on my PCB, I ordered ENIG, which is immersion gold, which gives it that nice, smooth gold finish. And then on, let's see. Yeah, so on the front side, I have all of my control connections, the LED, switches and all that stuff, power. And then on the back layer is where I'm routing all of my touch pads. And I also have a ground fill on that. And yeah, this is the biggest PCB I've made, and but it was still fairly cheap going through JLC PCB. I looked at Oshpark, and they have a much more aggressive pricing structure that's based on the size of the PCB. So I think to order this from Oshpark for 3 PCBs was going to be over $200, and that's the U.S. Manufacturer. But for the Chinese ones, I went with JLC PCB, and it was, I think, $50 plus shipping plus tariffs at this time. So the total ended up being about $100 to get 5 of these boards made, which all in all is not too bad. I also have my silkscreen, and I label out the names of the notes because I want to, I think that would help my kids when they're playing around with it to make the connection, because my daughter's taken some piano lessons. So I think if she plays around with this, it'd be neat to see the note names and to learn that way. But yeah, it's fairly simple. I have something to note. I have the touch pads, which are broken out from the MPR 121. You can have 12 touch connections on this, and I'm using all 24 with both of these. And something I did on this design is I routed these all the way to the center of each pad and did a via from the center. Now I did another test board, and I routed it to the top of the pad and then connected it there. And I found that the capacitive touch was much less sensitive. So I'm really glad that on this one I routed it to the center, and that was just dumb luck that I did that, and it worked well. But yeah, that is the PCB. So now I'm going to go through some of the code for the TouchedOut synth. And I'm using the Arduino IDE environment along with DaisyDuino, which is Daisy's wrapper to fit into the Arduino environment. And that lets me use the existing packages for the capacitive touch modules, the MPR 121. And what I did was I started from the Synth code repository for their products, which they've made open source. Specifically, this touch synth that they have, which looks really cool. And they use these neat capacitive touch sensors that have this kind of unusual design. So that's really where I started learning how to do this, and I watched a lot of their YouTube videos, which were helpful in designing the PCB and using the software. So thank you to them for sharing that knowledge. So here we have the .ino, which is the main Arduino file. And I'm not super well versed in the Arduino environment, but what I've seen I like, and it seems to make it very simple for combining different packages for different kind of hardware targets. So setting up the Arduino environment took some steps to get it working, but there are some good videos online, both on the Arduino side and the Daisy side. They have a nice tutorial about using and setting up DaisyDuino. So in this TouchSynth INO, I have all of my includes. I define all of the analog and digital connections. Some global variables for the looper and different effects. And then I have my touch functions. So on pad touch, when I touch a pad, the MPR 121 chip says, hey, there's a change in capacitance on this line, and it sends a signal on the I2C line to the daisy seed, and then all the processing happens on the daisy seed for generating the notes and all that stuff. So some if statements for if I'm touching a note or if I'm touching the octave pad or the loop pad. It does different things. I played around with what I called aftertouch. So if you hold a button, then it continues to read the capacitance level and send that. And I played around with some things on the keys to see if I could, by pressing harder or softer on the pad, change the sound. And it worked a little bit, but not quite well enough for my liking. So I ended up not using that, but that could be a future thing. Here's the main audio callback, which is the same as in the libdaisy environment. That would look the same. So just processing the looper, adding the reverb, getting the output from the oscillator, which is this Vox class. We'll go there in a second. Then in the setup, which runs all this when you start up the daisy seed, initializes everything, starts all the controls, and then this is our loop function, which exists separate from the audio callback, and this just goes on a loop. And so we're doing things in here like reading the analog and digital controls, setting variables based on those, and that's really it, reading the control inputs. So now we'll look at the code that does the capacitive touch and handles that. And for this one, I started with the example given in the Synth Simple Touch Instruments code, and I added the second MPR 121. So that's this cap is the first one, cap 2 is the second one. And you have to solder a pad on the back of that board to give it a different address. And so it knows which one does which keys. Have some callbacks when a pad is touched, when it's released. And then the main process function, which loops through and reads the state of all of the touch pads. And that's the second one. And that's it. And then I have my variable speed looper class, which builds on the looper class in Daisy SP. And it was pretty simple to add some things to make it a variable speed looper. You can go in reverse, forward, slow down, speed up, all that good stuff. And then this vox.h is the oscillator voice. It is a 8-note poly synth. You can play up to 8 notes at a time. And this handles it handles the oscillators. When you touch a note, turns it on and applies the envelope and filter. Each voice has its own oscillator, envelope, and filter control, and that lets me do filter envelope, which if I had more controls on the board, I could have that separate from the volume envelope. But right now, those 4 sliders control the envelope for both the volume and the filter, which gives it some cool sounds. I like the way it turned out. Let's see, anything else interesting? All of these are just individual callbacks for setting the the ADSR envelope, and that's attack, decay, sustain, and release. That controls the rise, fall, sustain when you hold the note, and release time of the note when you touch it. And when I first started playing around with synths, I was really surprised on how different the sound is based on how you control the envelope. You can make it sound like a piano or a trumpet or a violin just by changing these settings. I'm using the Moog ladder filter in the DaisySP library for the filter on that. But yeah, that is the whole thing. This is related to this DSP file is related to the looper. I needed to include that separately. But yeah, all in all, not too complicated. And I had that wonderful Synthux code to start with, and that really helped me to understand the Arduino environment, the capacitive touch, how that worked. And that's how I was able to make this synth. So thank you. Well, that is pretty much it. Building this was a lot of fun. I learned a ton, and I hope to do more with synthesizers and kind of standalone instruments in the future. So thank you for watching, and I'll see you next time.